Lorentz contraction of Einstein's special relativity. Einstein created a formula to demonstrate that the measured distances in the direction of movement contract. I will give you an example. If a spacecraft carries an observer inside and it goes at very high speed, the observer inside will notice small distances outside the spacecraft, less than what an observer heard will see watching the same spacecraft move. But this observer instead you will see the spacecraft from a smaller distance than what the observer will see inside the spacecraft. The size of a resting object is not going to be the same size as a moving object. Today I'm going to show you how to measure how much this distance has changed. A stick measures 2 meters while at rest, but it's not at rest. It moves at 0.9 times the speed of light. How do we know how much it measures going at this speed?
With this formula, the length at rest is equal to gamma multiplied by moving distance. I will put this in Spanish in the formula so you don't forget it. So sorry, Miss Nene. First, we will change our unknown, which is the distance of the moving stick. We will stop multiplying it by gamma and we will leave it next to the equal sign. Like that. With these values, we replace 2 matching gamma is equal to what we are looking for, which is the length of the stick in movement. With these values, we replace 2 matching gamma is equal to what we are looking for, which is the length of the stick in movement. Gamma is 1 divided by root of 1 minus the speed of the stick divided into the speed of light, thus 2 squared. That gives us 1 divided by root of 1 minus 0,8c, 1 minus 0,8c divided by c, thus 2 squared. The first thing we can do is to eliminate the c. That gives us 1 divided by root of 1 minus 0.8 squared. Then we square 0.8. We clean here first. .8 squared is equal 0.64. That gives us 1 divided by root of 1 minus 0.64. Then we clean here. And we have 1 minus 0.64, the same that 0.36. Then we solve it. We solve the root. And we have 1 divided by root of 0.36. That's equal to 1 divided by 0.6. One divided by 0.6, we can amplify by 5, and that gives us 5/3. We clean first here, 5/3. 5/3 is equal to 1.6 repeating decimal. That's equal to gamma. Now we can divide our length at rest in gamma. That resolving it gives us 5/3 or 1.6 repeating decimal. And that would be 2 divided into 5/3. and that is equal to 6 divided into 5. In decimal, it is 1.2. 1.2.
This stick contracts at that high speed and measures 1.2 meters. What we just did with our rod is used to know how much an object contracts in space. Now I will try with a pretty big galaxy called Hot Galaxy. I'll tell you right away what happens. Hello again! I tell you that the results were surprising, and its measurement at rest was 140,000 light years, and it's moving from us at a speed of 1/3 that of light. The measure I calculate of its distance moving away from us is 131,992 light years. How much this galaxy contracts is nothing more and nothing less than 8,008 light years. Conclusion: distances do not change that much either. It is only appreciable to us when the speed of the moving object is close to the speed of light, but it is amazing. Thanks for watching, and don't forget that everything is relative.